So we are going to move into our next speaker from Celo. We've actually got a Celo Power Hour coming up. We've got, we'll start with Marek. So you here?
I am. Can you hear me?
Yep, we can hear you just fine.
Amazing. So hello, everyone. It's really, really wonderful to be here. Thank you, ETHDenver, for having me. Once again, I'm Marek Olszewski. I'm the founder and CTO of C Labs, one of the companies building out Celo. You can find me on Twitter at Marek _. And yeah, today we're going to be talking about Celo. And so if you're new to Celo, we commonly say that Celo is a permissionless platform focused on making financial tools accessible to anyone with a mobile phone. But I think for this community here, I think maybe a better definition for everyone is that Celo is a Ethereum sidechain plus. So what does that mean? It means it's fully EVM compatible, it's scalable, we're building bridges to Ethereum. And as we just heard, it's going to be another talk right after this. And so if you're interested in bridges, I highly recommend sticking around to hear from the one and only James Prestwich. And then the platform also has some really amazing kind of bonus features, which I'll talk about in a bit, including a stable coin that's backed in part by ETH. But for now, I just want to start with a story about someone that I'm going to be calling Manuel to preserve their privacy. So Manuel lives in kind of the favelas in Lauro de Freitas in Brazil. Favelas, for those of you who don't know, they're kind of low-income informal settlements throughout Brazil. And Manuel, he heard about this kind of universal basic income program by a project called Impact Market. And he had a smartphone, so he figured he would sign up for this program in kind of this group onboarding session that you can see here on the left. And in that session, he installed a mobile wallet, crypto wallet on his phone, and the Impact Market DApp. And since then, it's pretty exciting. He's been getting an average of 66 cents deposited into a smart contract every day, which he can redeem directly into his wallet simply by pressing a single button on his phone. So perhaps not surprisingly, he initially would take those 66 cents and deposit and then cash them out immediately. But as merchants in the neighborhood started accepting Celo dollars, he now changed his behavior a bit. He now saves funds every week so that he can go to his kind of local grocery store and buy groceries directly with Celo dollars using his crypto wallet. So that's pretty exciting. And then since then, the Celo community actually voted to offer rewards for people holding Celo dollar balances in their wallets, which actually further changed behavior, increasing circulation in this and other communities, and increased the desire for people to keep kind of funds in their wallets and secure them using the blockchain. So Manuel's not alone. Impact Market now operates in 53 communities, which is really exciting to see. And in the last 2 months, they've grown incredibly to now over 10,000 beneficiaries. And you can see this is a heat map of where these communities are located. And once again, folks are receiving on the order of 60 cents kind of a day. Now, this is what the app looks like. It's completely mobile first. It's completely open source. And by using the blockchain, they estimate that they're an order of magnitude, they have an order of magnitude less overheads than other direct giving programs that aren't crypto-based. And so it really epitomizes what a Celo dApp looks like. And if you guys are interested, they recently opened up their beta to anyone, and so you can play around with the app simply by going to impactmarket.com, and then you'll see the two links to two stores. And then if you're interested, of course, please consider donating. Again, your funds go directly to these communities. Now, why did Impact Market build on Celo? I think that's the question that we're looking to answer in this talk. And it's likely because Celo had really everything that they needed to build kind of that end-to-end experience that we just kind of walked through. And I would argue that the reason the platform has kind of the features that are necessary to build that experience is because the platform was built in this kind of mobile-first manner. So the community didn't just want to build a new and more scalable blockchain. The community wanted to build something that would allow people to build just incredible mobile experiences on top of it. Now, you might be asking, why mobile? Is mobile really important? Do people even have enough smartphones out there? This is a common question that I get asked. And the answer is a resounding yes. So here's a graph by the Ericsson Mobility Report. It shows that 2 years ago now, globally, we have crossed 8 billion mobile phones that have active mobile subscriptions in the world. And just last year, we crossed the 6 billion smartphone mark for the number of smartphones that have active mobile subscriptions. That is a staggering, absolutely massive number. And then if you look at these colors, you'll see that network connectivity is also rapidly improving globally as well. So already this year, we're talking about 80% of global connectivity is 3G or better. And so that means that people are able to load the internet with decent or even incredibly fast speeds. Now, the rest of, I would say, the tech sector has figured this out, I would say maybe 10 years ago. But, you know, somehow Web3 is still predominantly building kind of for desktop computers first, and then only mobile second. And so in an effort to change that, when we built the Celo platform, we, in parallel, actually even to some extent before, built an incredibly easy-to-use wallet on top of it, which we're calling Valora, that really helped us shape kind of the features that needed to go into the underlying platform that would then allow kind of the experience that we were looking to build in the actual mobile wallet. And so you can think of Valora as a permissionless Venmo. It's super easy to use. It's focused primarily on payments. It has a fully decentralized phone verification onboarding, and it connects directly to the peer-to-peer network using a light client protocol instead of connecting to a centralized backend. And this is all thanks to all of these features of the Celo platform that, again, have really been built in service of Valora. So what are these features? There's three primary ones that I wanted to cover today. And the first is around stable value. The platform has a built-in native stablecoin platform that lets you launch multiple stablecoins that are all backed by the same over-collateralized crypto asset reserve. It's a hybrid of kind of the seigniorage share model that I think Base popularized and the kind of the crypto collateral model that the Maker uses. So you can think of it as a bit of a best of both worlds. And what's nice, by sharing the reserve, multiple assets can be quickly rolled out. So the Celo dollars launched last summer, and the Celo euro is about to launch next month. And perhaps most importantly, these stablecoins are actually implemented as ERC20 tokens on the platform. But in order to make it really, really easy for people to send them around, you can actually pay for gas using ERC20 tokens on the Celo platform. And so that just makes it much, much easier to interact with these stablecoins, to, if you receive one, to send it forward to someone else without having to maintain a balance of another asset. And clearly Manuel finds that very, very helpful when he redeems his UBI and then goes and pays for groceries at his local store. Again, he doesn't have to think about gas and other currencies that he has to maintain. So that's the stable kind of platform. There's also a kind of built-in identity protocol that effectively maps hashes, uniquely salted hashes of phone numbers to public keys. And then there's a decentralized phone verification protocol that lets you verify your phone number in order to add one of these entries. And this makes it really, really easy for folks to send payments to phone numbers instead of to public key derived kind of addresses. And so critically, what that means is that you can actually send payments to people directly in your contact list. You don't have to go and request an address. You can look them up by name in a traditional kind of search box that you and me know from centralized services. And they can be in a different wallet. It doesn't even have to be the same wallet. And it becomes really, really easy to send payments to anyone that is kind of in your address book. And perhaps more importantly, you can also send the payment to someone before they've actually signed up. So before they've actually created their private key and derived their public key and their address, you can send money to a phone number, and the wallet automatically puts those funds in an escrow smart contract. And then the recipient, when they verify their phone number, can request those funds automatically. Excuse me. And then finally, I mentioned that Valora connects to the peer-to-peer network using a like-client protocol. So when we built the consensus protocol, we worked really, really hard to create an extremely efficient like-client protocol. One that at launch is or was 17,000 times lighter than what's typical for other chains. And we do that through kind of two techniques. We use what we call epoch-based syncing, which means that in the proof-of-stake protocol, the validator set can only change once per epoch. Our epochs are 1 day, so once per day. This means that a like client only has to download the last header of each day. Secondly, we use BLS signature aggregation. So all these signatures from all these validators, they all get aggregated into a single multi-sig. That saves a lot of space in headers. And then finally, since 17,000 times lighter wasn't actually enough for us, we wanted it to be just blazing fast, competitive with centralized offerings. We worked incredibly hard to create Plumo, which is a ZK Snark-based like-client protocol that is actually 1.7 million times lighter. Plumo is coming out in the next hard fork in about a month and a bit. And once it launches, like clients can simply download a 500-byte snark proof that they can verify in constant time really quickly. And that proof allows you to sync up to a year's worth of headers, again, with just 500 bytes. So that is incredibly lightweight. Excuse me again. So maybe switching gears a little bit, what about scalability? Any chain worth its salt these days has to be extremely fast and scalable. And to that end, Celo uses a kind of BFT-based consensus protocol. We talked about those signatures being aggregated, and then kind of a proof-of-stake network on top of this that I would say has many, many similarities to Polkadot. It uses the Hans algorithm to select validators in elections that are based on how much stake is voting for specific validator groups. The network launched with 5-second block times, but this can be trivially lowered through on-chain governance. Everything on Celo is governable through on-chain governance. Now, the light client that we just talked about, it turns out it's also useful for scalability. Syncing is clearly an issue for full nodes joining the network. And luckily, a very efficient light client makes fast mode a lot more efficient as well for syncing, which is really great. We want to make it as easy as possible for full nodes to come and go from the network, which as the network gets more load becomes even more important. And then perhaps most importantly, the platform also has full node incentives. So even if the size of each block goes up and machines have to get a little faster in order to keep up, there is an incentive for these full nodes to stick around and not drop off, because they actually earn money simply by serving light clients on the network. And so full nodes actually get a cut of every transaction that they forward from a light client onto towards the peer-to-peer full node network. And so that incentive is critical. There's a lot of debate around increasing block sizes on many chains. And the common argument against doing it is that the network becomes less decentralized, full nodes start dropping off, it becomes too expensive. And so we wanted from the get-go to have a incentive mechanism to keep these full nodes around. And so luckily we were able to come up with something that works pretty well and really works nicely for connecting kind of those light clients running on those mobile devices worldwide. Now, none of this actually matters if there's no ecosystem around it and there's no users. And certainly, DeFi developers really, really care about what's going on in these chains. Is there enough liquidity? Are there other projects that I can compose with? All of those things. And the answer is that super excited and happy to share that there's a lot of DeFi already happening on the platform. So there's decentralized stablecoins, as I mentioned. Celo Dollars is already live, and Celo Euros is launching next month. There's been an on-chain DEX that's been around since July called Mento, and another one called CoraSwap that's about to launch. There's a lending market, Mula, that is very, very similar to Aave and Compound, that is just coming out of beta right now. TBTC is looking to launch on Celo very soon, and we've already heard about Impact Market. And on top of that, there are literally hundreds now of companies that have committed to building on top of or integrating with Celo through the Celo Alliance for Prosperity. And so there's a lot of activity happening on the platform, and a lot of really, really good opportunities to compose with other projects and to benefit from liquidity and other integrations. Speaking of liquidity, I think many people frequently ask about on and off ramps. And surely a network that has launched less than a year ago doesn't have any good options. And on that front, also absolutely humbled and excited to share that there's been a lot of interest from exactly these kind of companies that provide these kind of services. So already MoonPay, Simplex, Bidali, and Ramp all support Celo currencies. Wire, I believe, is actively working on adding support literally right now. And many of these are directly already integrated into Valora. So it's just really, really easy to cash in and out of the wallet. And so if you're interested in learning more, especially if you're technical and you want to look into the SDK docs and dig into some code, then I highly, highly recommend checking out docs.celo.org, where there's a lot of good technical documentation. There you'll read up about ContractKit and DAppKit, which are kind of our two really big and popular SDKs. Also, highly recommend joining our Discord at chat.celo.org. Pretty easy to remember. There's a whole community there of folks who are very excited to chat and offer any support if you have any questions. You might also be asking about funding. And on that front, we're also thrilled to have a lot of funding options throughout the community, really regardless what stage you're currently at. And to see all of those different options, go to funding.celo.org. There are fellowship options, grants that you can apply for and easily get if you're a little earlier. There's an incubator program called Celo Camp that's on its third incarnation right now. Highly recommend that. There's also VC-style funding from folks like Flory and Polychain through the Polychain Celo Ecosystem Fund. So definitely highly recommend checking out funding.celo.org for more info. And then finally, if you're interested in just hearing more from the broader Celo community, highly also encourage you to sign up to Kaneko.celo.org. It's our community all hands that happens once per quarter. And you can sign up again at Kaneko.celo.org. And the next one is happening really soon on February 18th. And I think that is all. Again, really great to be here. Thank you so much for having me. I highly recommend checking out these links to stay connected. And once again, I'm Marek Olszewski with @Marek_ at Twitter.
Thanks, Marek. Thank you. We appreciate it. And we're just going to pass it right to your colleague, Mr. Prestwich.
How's it going, John?
Doing great. So you ready?
Yeah, now that I figured out how to use the microphone. All right. Hey, everyone. I am giving the follow-up to Marek's talk. You had me at Celo Act 2. And Marek gave a great overview of this Celo ecosystem and where things are today and why we decided to build it this way. And I'm going to talk about my favorite thing to talk about, interoperability. If you've seen me speak before, a lot of the elements of this are going to be familiar, and that's because I'm really kind of a one-trick pony here. I just spend all of my time kind of bike shedding these interoperability systems. Apologies there. I work on Bitcoin, Celo, Ethereum, Near, Solana, and a bunch of other chains. I'm always building some sort of cross-chain relay or interoperability project. I recently, a few months ago, joined Celo full-time to head up interoperability projects. And I'm going to spend time today going through, what is interoperability? What's a bridge? How does it work under the hood? And why does it work that way? So our goals right now are to talk about bridges first and getting an intuitive understanding of bridges. I'm going to give an overview of what we want a bridge to do, why we want to do it, and then I'm going to describe cross-chain communication, the primitive that underlies these bridge applications. And after that, we're going to talk about a couple different models for cross-chain communication. If we've got the high-level application and the underlying primitive, how do we actually build that out in practice, and what are our choices? So throughout the talk, I'm going to be using kind of standard flowchart diagrams. The rounded rectangles are start and end. The parallelograms are inputs and outputs from the system. Squares are steps, and diamonds are decisions. There are quite a few decisions, and you may have noticed I've only got one output from it in this chart. If you only see one outgoing whisker from a decision, it means that the other path is everything falls apart, you do not have a bridge today, and we have to rebuild the system from scratch. We like taking the happy path because the unhappy path is you do not have a cross-chain application. All right, so we're going to talk about bridges specifically. This is the problem statement for a bridge. I have Celo, Ethereum has dApps. I'd like to take my Celo and go use it in Ethereum's dApps. And more generally, there might be any information on the Celo blockchain, and some smart contract or some other chain might want access to that information. This could be assets like tokens. This could be whether a loan is collateralized enough or not. It could be like the identity of the current validator set. There's a lot of different things that you might want to use in another blockchain. We want to get that information out of one chain into the other, and we want to do it safely, quickly, and securely. So, from a high level, this is what a bridge does, is it locks up Celo, and then on some other chain, it's going to mint ETH Celo, so we can go use that in dApps. And when we want to get our Celo back, we just do the whole process in reverse. And that's why I've put the exact same chart in reverse here. We pull it out of our dApps, we burn the ETH Celo, and then we want to unlock the Celo. So, the part that makes it a bridge is this minting and burning step. The goal of the bridge is to make sure that the amount of Celo doesn't go up or down. We lock some up, we create some new ETH Celo over there, and then we destroy the ETH Celo to get it back on the original chain. The bridge is an application. It's not a technology itself. It's not a primitive that we're using here. In order to build the bridge, we're going to need some sort of technology to get across these big fat boundaries between chains. We're going to need to get something out of Celo and into Ethereum. We're going to need to get information out of Ethereum back to Celo. And in order to do that, we're going to build out some technology, and we've got to do it twice here. You can see there's two different boxes, and that's because these minting and burning processes are actually unrelated. The application of the bridge wants them to be related, and we want to kind of enforce that supply doesn't go up or down. There's no inflation, and we don't actually pitch your Celo out into space. The thing we got to plug in there is some sort of one-way communication channel. We have to build some, like wire, some telephone system that connects Celo to Ethereum, and then another one that goes the other way. So bridges, they rely on these cross-chain communication channels. And the thing about cross-chain communication is that it's what we call simplex. It only goes one direction. We can't have a two-way telephone conversation like you and I would. Cross-chain communication is always one direction, and that means we need two of them. Bridges use two independent one-way communication channels, and those two channels succeed or fail independently. And how we build them can be different. The same bridge can use two different, completely different security models for these channels. And we would love to bundle those into one channel and go both directions, but unfortunately, duplex channels aren't possible. Building these two one-way channels is literally the best we can do. It's the closest we can get to two-way communication. A chain has one way of receiving messages and no way of sending them, and we need to figure out how to kind of fix that. All right, so we've talked about bridges from a high level. They want to lock up tokens on one place and mint them on the other. And then they want to destroy them over there to bring them back and unlock them on the original chain. And what's so hard about them is we have to design and run these two low-level communication channels. And those are really complex. So we're going to talk for a few minutes about why they're hard. We're going to go in from kind of first principles and talk about one-way communications. We've established our bridge needs two of these. How do we build them? This is what we wish would happen. I wish that I could just on Celo send a message and know that a dApp on Ethereum will get it. If it worked that way, then we wouldn't worry about bridges at all. It would take like 15 minutes to build one, and it would be nice and easy, and everyone would be happy. Now, unfortunately for me, this is the actual situation. You just can't do that. We have these big walls around the chain, and information can't get out or in very easily. The dApp can't just receive that message. It's on Ethereum, and it needs an Ethereum transaction. It needs that message to be put into a TX. So we need to send that Ethereum transaction to kick off the dApp. Okay, but so you might think we can just have Celo dispatch this Ethereum transaction, and then we'll have Ethereum process the transaction, and then the dApp will get the message, right? Well, you know, unfortunately, Celo can't send Ethereum transactions. It doesn't have an Ethereum wallet built into it. I don't think that's really like a feasible thing to be doing. You can't put a private key into a blockchain. The Celo chain just can't sign an Ethereum transaction. In fact, chains can't have any outside effects. The only thing that they can do is read an incoming transaction and update their own state. And that makes sending messages really hard. You know, we can't have Celo directly trigger an action on Ethereum because Celo can't send a transaction. And if it did, Ethereum wouldn't get it. So we have to add this new intermediary. In order to get a message off of Celo, we need to have some person off-chain running software. The software has to watch Celo for messages. It has to decide whether to forward it. And then it has to choose to dispatch an Ethereum transaction containing that message. Then Ethereum can process that transaction, and then the message can be received at the dApp, by the dApp. So we have a bunch of steps here, right? Celo updates its own state to commit a message. Someone sees that message, someone forwards it to Ethereum, Ethereum processes the transaction, and then the dApp gets the message. This is much, much more complicated than Ethereum smart contracts calling each other, where you just like, you know, one contract sends a message and the other one gets it immediately. And that's why, you know, there are very few bridges out in production today, is they are inherently much more complex than, you know, same chain transactions. We're still really figuring out how to build and deploy these reliably. All right, so we talked about this a little bit. Chains are passive. They can only respond to transactions and update their own state. Communications need to be active, and that's why we need this off-chain intermediary. They're watching Celo and forwarding to Ethereum. And going the other direction, they have to watch Ethereum and forward to Celo. It's impossible to run communications without some off-chain party doing that message observing, forwarding, and ensuring it gets processed on the remote chain. The kind of taxonomy for these communication channels is determined by how we check that party's work. What is the trust model for that off-chain intermediary? And so that brings us to the third part of the talk. What are trust models? Who is running these things, and how do we decide whether they're reliable? We have this intermediary, and they're responsible for performing certain roles, and we want to force them to perform that role. Now, unfortunately, the sending chain cannot know if its message was received. It shouts this message off into the void, and it relies on the off-chain actor to do their job. It gets no guarantees. And so we have to add one more step. Because the sending chain, the origin of this message, cannot know if it was processed, we have to make sure that the destination chain enforces that. And because the destination chain can't directly read the sending chain, we have to have it authenticate this message. Otherwise, our intermediary, our off-chain actor, could commit fraud and submit messages that were never actually dispatched from Celo. So, you know, we have to add this one more step here. We have to, when we see a TX on Ethereum, on the receiving chain, we have to decide whether that transaction is any good. And so between starting to process the transaction and sending the message to the dApp, we need some on-chain Solidity contract that looks at the transaction, looks at the message, and figures out if it's good. So we got to define in Solidity, this programming language, how we tell if a message is any good and whether we should process it. What we're really talking about is what makes a message trustworthy. A message, how do we know we can trust it? And if you want to be very, very like procedurally oriented here, we have to know what makes a message actionable. At some point, we got to say, yes, we're going to forward this to the DApp and it's going to do something, or no, we're not. We need to commit. And the code that needs to commit is going to be running in Solidity on chain. So that code needs to be relatively cheap. It needs to be deterministic, and it needs to create high confidence in this message. The ways we get confidence are what we call trust models. Now, I'm going to talk about two, but there are a few more out there. The easy one, the one everyone loves to use because it's so cheap and easy and fun, is called proof of authority. In this case, we're actually talking about proof of James, right? I'm going to be the intermediary, and I promise that I am only going to forward valid messages from Celo to Ethereum. And so what we're going to do is, in this full diagram, I'm going to perform all these middle steps. I'm going to be the only off-chain guy, and I'm going to forward everything to Ethereum, and I promise I'm going to do it right and not like censor anything or commit fraud. And then all Ethereum needs to do is check that I signed the transactions. If I signed it, they're good. We can move on. We can send messages to dApps. So what are the kind of pros and cons there? The pros are that messages are small and cheap and fast. All you have to do is check my signature. The cons are that there's a single point of failure. If I go offline, the whole bridge dies. If I start selectively censoring transactions, you may not be able to use it. If I decide to steal your money, there's nothing you can do about it. So we say that the failure modes are kind of catastrophic here, right? Is with proof of authority, if the authority ever becomes malicious or just wants to get your money, there's no way to stop them, and they just get it all. We'd like to avoid that. We'd like to find some better security models. After all, I think that's what got a lot of us interested in blockchains and smart contracts in the first place. So another alternative for cross-chain communication is what we call relays. And for a relay, the destination chain is actually going to run the consensus process of the sending chain. So for Celo and Ethereum, this means that there is a Celo light client embedded in Ethereum. This doesn't exist today, but we're optimistic that at some point in the future it will. The only running relay out there right now is the Bitcoin relay that's part of TBTC. I built that. It relays Bitcoin headers to Ethereum and runs a full Bitcoin light client in Solidity. So the goal here is that we're going to do exactly what the sending chain does. We're going to do the consensus process of the sending chain. We're going to run this little light client. We're going to process all the headers. If it's proof of stake, we're going to do all the validator set updates and changes, and we're going to keep track of who's validators. So we're actually like running the consensus process. I see someone in chat saying there's a POA relay. That's not a relay, that's a proof of authority. So let's talk about relays. The goal is to get as good security as any wallet of the other chain gets. And we're going to do that on the receiving chain. And if we do this, then we can validate proofs of the other chain's state and of events on that chain. And so this is how a proof of work relay works in the wild. You're going to get an incoming transaction. It's going to be either a header or an event. If it's a header, we're going to append it to our chain. We're going to first check that it extends our known chain, that it is building off of a header we already know of. So then we're going to actually check the proof of work. For Bitcoin, we're going to do the double SHA-2. We're going to see all those zeros. We're going to see that it extends a header, and we're going to append it to our local view of the remote state. We're going to append it to our header chain in Solidity in a smart contract. If it's not a header, it's probably a transaction. So we're going to check if that transaction is in our view of the remote state. That means checking if we know of a header that confirms that transaction, right? So in Bitcoin, this means that you get your transaction, you use a Merkle proof to connect it to a header, you check that that header is in the header chain that you know of and that it's buried a certain number of blocks deep. And then we can check if that transaction contains a message, and we dispatch that message to the dApp. So the key thing here is that we're doing proof of work. If the proof of work is working, we get transactions that have actually occurred on Bitcoin, and we cannot receive a transaction that didn't occur. So we get high confidence in these messages. So for proof of stake, it works very similarly. The transaction processing, the message processing is just the same. But because we're actually running the consensus process, the rest of it, the header chain, works really differently. Proof of stake requires a trusted setup, for example. Someone has to start off the relay by telling it who the current validators are. And then every time the validator set changes, we need to update the relay with information about that. If we miss some of the validator set changes, the relay may be with an out of date. It may have an old validator set, and that old validator set could potentially defraud the relay. And so we have what's called a synchrony assumption. The relay must be updated with a certain frequency for proof of stake, where it falls out of date and becomes less reliable. You have less confidence that the information is actionable. But generally speaking, all we're doing here is running a light client. We're following the validator set. We're checking that they sign block headers, and we're appending them to our chain. And we're doing that in Solidity on Ethereum. Building these is complex and annoying, but isn't actually that bad. The main differences are the trusted setup and keeping track of the remote signer set. And if you do it right, you actually end up with a view of who all the signers are, what their balances in Celo are, and you keep that view updated over time. And you can accept their signatures on any given header because you know that the POS is done right. So for relays, the off-chain actors can be anybody. Because the remote consensus system, proof of work or proof of stake, is public and objective, anybody can forward those headers or those transactions over. There's no need for this permissioned intermediary like me or like a POA bridge. Anybody can ensure that it operates correctly. And that's a really desirable property. And in the smart contract side, when you process this incoming transaction, you run it through the relay to check that it's good. And that way you can have this publicly maintained bridge with no permissioned parties, and everybody can contribute and can verify that it is behaving correctly. All right. So the pros are that it's about as good as the remote consensus set. If the proof of work is working, the relay will work too. If the proof of stake is honest, the relay will be honest too. There's no need to rely on this trusted authority figure. We get economic security. The cons are that there's a lot of overhead. For proof of work, we have to transmit every header. So every time there's a Bitcoin block, we have to send a Bitcoin header, and that gets expensive. And for proof of stake, there's a trusted setup that may need to be repeated. If we fail to update the validator set on time, we may have to do another trusted setup, and everybody has to be kind of comfortable with that idea. So those are the two security models, and I'm running out of time, so I'm going to quickly add a couple notes. What is sharding? You may have heard of this in the context of ETH2 or NEAR. Essentially, sharding is doing the relay on the consensus level. So you're doing this mandatory relay instead of doing it in a smart contract. And with sharding, you get this guarantee that failures are known about. So if the one shard fails, you definitely learn about it. Whereas with a relay and a smart contract, if the other chain fails, you may or may not learn about it. So sharding is like this strictly better, stronger guarantee for a relay. And what about atomic swaps for cross-chain communication is kind of like, what about them? They don't really work or do anything. They have very bad user experience and can't transmit arbitrary messages, which means you can't use them to wrap assets or do most of the things we want out of a bridge. And that is about it for my prepared remarks. I think I've ended just about on time. Thanks everyone for coming out today. Feel free to ping me on Twitter if you have any questions or anything like that.
Well, thank you for coming. We appreciate it.